just multiplying, or excuse me, or just a comparison between two quantities or numbers using division. And from years past, hopefully you recall, there's three main ways to write a ratio. There's, say, A to B. You can write it with words. Or you could write it using what's called a colon, using division. You could compare them. Instead of using the word to, you could symbolize the word to with a colon. Or most importantly, what we're going to focus on is we're going to compare them using a fraction. Okay. Since fraction bars just mean divide, we'll compare using a fraction. These three say the same thing, comparing A to B. Okay. If you have an equation that compares two ratios, or an equation of two equal ratios, that's called a proportion. And those are some. The idea of a proportion is very fundamental to math and science in particular. We use proportions all the time. We'll show a couple examples of proportions at the end of the class today that either already use or if not you will be using very shortly. And we generally write this as, say, we'll compare, say, like A to B is the same as C to D. Would be just in general an example of a proportion. Two ratios that are equal. Okay, so I want to write some ratios. First of all, here's an example. Say U of M softball team plays 10 home games and 25 away games this year. They're on the road a lot. The North team is bad weather early on, so they play a lot of road games. Write a ratio comparing the number of home games to number of away games. So what would be, what's the first ratio we can set up?
10 to 25.
10 home games to 25 away games. But we want to make sure, we want to reduce this at all possible. So we want to write, our final answer will be the reduced ratio. How is 10 over 25 reduced down to?
2 by
5 goes into each of those, twice in the 10, and 5 times in the 25. The ratio of home to away games is 2 to 5. How about a ratio comparing the away games to the total number of games? So, away to total. Now, how many away games are there?
25.
How many total games are being played?
35.
How'd you get that? If you add the home games to the away games, you get all the games played. So the ratio of away games to total games should be 25 to 35. Reduce this fraction, because 5 goes into each of those, and you get 5 away games to 7 total games. Would be the reduced ratio. 13 different kinds of cards. There are 4 suits: spades, hearts, diamonds, and clubs. The hearts and diamonds are red. The spades and clubs are black. And the other classification of the cards are called face cards and not face cards. Face cards are kings, queens, and jacks. If you look at a deck of cards, they have like pictures on them, as opposed to just like the number of just numbers. So kings, queens, and jacks. These are called face cards. Just as some background information if you weren't familiar. If you already knew that stuff, awesome. If you didn't, then here's some background knowledge. So what I'd like you to do is go through and quickly on your own, if you could, write down ratios comparing these 4 different things. Red cards to black cards. Hearts to every card. Queens to every card. Face cards to not face cards. Well, the ratios I'd like you to compare to. Okay, and jot those ratios down. All right, let's see. Red to black. There are 26 red. There are 26 black. So this reduces. Now, 26 over 26 is 1. But we're writing a ratio. And a ratio should compare 2 numbers. So I still want you to compare 2 numbers. So writing 26 and reducing this still could compare 1 to 1. Okay, if we're writing a ratio, it needs to compare 2 numbers. So if I just write the whole number 1, that's not comparing anything. That's going to compare 1 to 1. Hearts to all cards. There are 13 hearts, and there are 52 cards in a deck. 13 goes into each of those once and 4 times. Queens to all cards. There are 4 queens, and there are still 52 cards in a deck. 4 goes in each of those once and 13 times. And face cards to not face cards. I explicitly said there are only 12 face cards. And how many not face cards are there then? 52 take away 12 is 40.
Is this what people do to count cards?
Some of it, yeah. Or you could just number all those. You go. Reducing these, the number 4 goes into each, 12 and 40, 3 and 10 times.
Yes.
One strategy, folks, one strategy for solving a proportion is to what's called use a cross product. Okay? A cross product is just multiplying we'll multiply diagonally that's an LT. Multiplying diagonally over an equal sign to create a new equation from a proportion. Cross multiplying looks like this. If you have a proportion, that means you have something that looks like this. You have like A over B is equal to C over D. That's our proportion. To cross multiply, we'll multiply on a diagonal over an equal sign. So this is the same as A times B. That's equal to B times C. So like on example A, solving this proportion by cross multiplying. We have a proportion, we have 2 fractions that are equal to each other. So we can use cross multiplying or multiply on one diagonal and get, say, 8 times 10. And that should equal multiplying on the other diagonal. 5 times x. In this case.
Does it matter which one you...
Exactly. So then once you've cross multiplied, now you've got an equation with no fractions, and now we'll solve it just like we've done in the past. So combine like terms or simplify. So you get 80 equals 5x. Get x by itself by divide by 5.
80 divided by 5 is what?
14.
16.
With 16. If your fraction has, say, has, say, what's called a binomial, or has two parts to it, start by putting parentheses around each part so they're grouped together. Okay? Start by grouping your numerators and denominators together is a good start. And now, cross multiply. So we'll multiply on the diagonal over the equal sign. So you'll have 7 times x minus 4. We'll have 7 times the numerator, 7 times x minus 4. And that's equal to 28 times 6. How are you going to solve this equation? What's your first move?
7 times
You could distribute. 7 times x is 7x.
We do plus negative.
minus
You could do plus a negative. What's 7 times negative 4?
negative.
And 28 times 6 is 168. Now your two-step equation. How do you solve this?
Add 20 both sides.
Undo this negative 28. So add 28. And get 7x equals 196. Get the x by itself, so divide by 7. X is 28. So if the x's don't start above, then who cares? You're still cross multiplying. We're still multiplying on the diagonal. 2x times 6 is equal to negative 12 times 11. Simplify and solve.
Yeah. Can I go with you?
We won't be very long. 2x times 6 is 12x. Negative 12 times 11 is negative 132. Divided by 12. X is, what, negative 11? Okay. If we start with what's called a binomial, if you have things added together, group them together. So start by adding together, group them, group the numerator and group the denominator, and cross multiply. So we could say, here's the one group to multiply together. 9 times, oh no, there's decimals, we'll survive. And that's equal to, cross multiply, 2 times m plus 0.3. Distribute. Yeah, what? 9m plus negative, plus a negative, negative what? 28.8 equals 2m plus 0.6. Variables on both sides. What do you do when variables are on both sides?
You have to
Group them on one side. So I like, as we said last week, I like grouping them on the side with the larger of the x's. So I'll group them on the left side because there's 9 x's as opposed to just 2 here. I'll subtract 2 m's and finish solving. Get a value of m. Okay. Please do E and F on your own right now. And come around and I'll come around and give you some help. And then if you feel, if you're up to it on your own, jump into the story problems. If not, we'll go through them before we leave. Group, multiply,
Negative.
Oh yeah, I forgot that's how you
group and multiply, distribute.
I forgot how to do that.
So sorry, that's what it looks like a two.
R is 2. So we got R is 2 and D is 5. On the map, let's say we're on a map. Say like you're in science class, because you're looking at maps. And you say that you have a distance between two places is 3.8 centimeters on your map. And the scale is 1 centimeter to 25 kilometers. Estimate that difference. So let's set up some comparisons or proportion involving some things on here. So if we compare, say, map distances to actual, what are two comparisons that should be equal? Well, the map scale, 1 centimeter in the map is 25 kilometers in real life. And that should be equal to, well, 3.8 centimeters that I measured. 3.8 centimeters that I measured. And how far is it between those two? Do you know? No. So if you don't know, what can we do? You could say put an X in there. And then if you solve this proportion, you could come up with X, or the distance between Red River Gorge and Pine Bluff. So that's like your X. You could cross multiply and solve. And come up with a distance. Similarly, if you say we're measuring 25 times 3.8.
Okay, that's like upside down R.
Thank you. Better.
You could also say set a proportion to find the second one. It says seals in an aquarium each are fed 8 pounds for every 100 pounds that they weigh. So if they're fed 8 pounds of food for every 100 pounds that they weigh, here's one ratio. This should be equal to, well, what would be another ratio that we can set up? Well, if we know
X over 280.
we also know that our seal weighs 280 pounds, so that'll go on the same side of the fraction bar as our weight. And we want to know how much food to feed it. So you can set up a ratio of, say, 8 to 100 should be the same as X, or the amount of food we're going to feed this little guy, to its weight, 280. Cross multiply and solve. And you can say 100 X is equal to 8 times 280. 100 X is equal to 1840.
So that would be.
What's that? Equal to 2240. So this seal would need about 22.4 pounds of food per day.